I've got a fraction of a circle, a portion of the circle. I need to know like what amount of the circle that is. So I think of it as like what fraction of the circle. Last class, someone in here on Monday threw out percent. You could be like, what percent of the circle is that? That's totally great. It's going to be 75 out of 360, getting that 75 degrees from that central angle right there. 75 out of 360 is approximately 0.21. So I could say then that this is about 20%, 21% of my circle. I could also say that it's 1/5 of my circle because I just happen to know my fractions, and that 1 divided by 5 is 0.2. Okay, so it's 1/5 of the circle. It's about 20%, right? That's what that means. 20% is 1/5 of a dollar. You know, all these things. Okay. So that's how much of the circle I'm talking about. So if I want to talk about sector area, first I need to figure out the total area. Now the total area for our circle, r squared times pi. We have a radius of 10. 10 squared times pi gives us 100 pi square inches for our total area. All right, area of the whole circle, 100 pi. Oh, okay. Let me be clear that this is like strike 3. Okay? I will literally kick out your whole table, Queens, if you're talking while I'm talking.
I was just telling Louise.
It doesn't matter.
Don't talk. Just
I
say
can
okay.
barely hear myself. My
Just say
head's
okay.
feeling like it's exploding. I don't feel good. I've tried to preface this several times now. Don't talk while I'm talking. Okay. Oh, it's 20%. This is 20%. This is 50 dollars. Nope. Okay, so total area is 100 pi square inches. So if I want to figure out then just this portion, what I'm going to do is for the sector area, the sector area is going to be that fraction, that percent, that proportion times 100 pi. Right? So I'm going to take, this is essentially kind of like my multiplier, like we talked about it before. So I need just 20% of 100 pi, and when I multiply that out, I get 65.97 square inches. Now that's a rounded answer, so you might have something slightly different than that. But please make sure you include your units. We're talking about area, it's a square measurement, square inches, great. Okay. So this is the way I do it. I think about this as a whole. Some of you guys like broke it down into degrees, or like found, there was weird, I'm not sure. I forget actually, I remembered it at the time, but I don't. All right. Questions on sector area? Anywhere where you're like, Ms. Dolce, you just went super fast, you lost me. That's 65.97 square inches. Yeah. Yeah. What? Okay. Okay, so now we're going to do pretty much the same thing, except when I'm talking about arc length, right, when I'm talking about this distance right here, now I'm talking about, that's a portion of the circumference. So now I'm talking about that distance around the circle and saying, okay, I want this portion of the circumference. And it's going to be the same portion. It's going to be about 20% of the circumference as well. So to find the arc length, first I'm going to find the circumference of the whole circle. Circumference of the whole circle is going to be 2 times r times pi, which is going to be 2 times 10 times pi, which will be 20 pi inches. Not square inches, we're just talking about a length of 20 pi around that whole circle. So then to find the arc length of that green piece, again, it'll be 20% of this 20 pi, so it'll be 0.21 times 20 pi, which will give you about 13.19 inches for the arc length. So this piece up here, being kind of a crucial step, right? Figuring out what ratio or fraction or portion or size how much of the circle we're talking about is kind of the crucial step, okay? And we can do that by thinking, hey, 360 degrees of the whole circle, we're dealing with 75 of those, there we go. So these two steps are fairly similar. Okay. Questions on either of those? Overarching questions? Questions in general? Questions about how I did it? Anything at all? Did anyone watch that excited Sue video? You did. Oh my god. What? It's pretty good. Should we bring balloons? Yes! You'll watch it and then you'll know. And it was because Mickey got really excited about it. Okay. Anyway, the other thing that I have to tell you is, I'll tell you later. You have 4 minutes to talk about your homework. I need all of you to have the same thing. I need you to come to an agreement on your homework. 4 minutes. If you didn't do your homework, here's a good idea, do it. Second thing, this is the last time, hold on, your 4 minutes hasn't started yet. This is the last time I'm going to say this. You may never ask me again for, can I have a copy of the homework? I was absent, I lost it, I don't care about whatever your reason was. Here it says text geometry. In the very front is a folder. It's manila. Yeah. And inside of there is your homework. Oh my gosh. If they're all gone, don't ask me to copy you another one, because I don't know why you lost it in the first place. Okay? If you grab it, great. That's what your homework is, don't ask. So, all we should have homework done by now. By the end of this 4 minutes. Make sure you agree on all the answers, mostly a vocab thing. 4 quick minutes, please keep your conversation focused and centered around mathematics. This didn't print very well. There were some symbols that were missing, but I'm okay with it. You probably called BC just as it's labeled. You called it a chord. It was supposed to be an arc, but it doesn't matter. BC as it looks is called a chord, or, which I know none of you wrote the secant line. Okay? Because you don't know what a secant line is. Now here's why. Let me tell you that ED and BC are two different things. And this is why we haven't spent a whole bunch of time talking about this, because I don't really care, and I'm not going to waste more time than that. I will say that notice that ED here, this has some points at the end. BC is a line, noted by its arrows on either side. And technically, this thing, ED, is a line segment. It is part of a line. There's a distinction. Now, when I was in high school, we spent about a month talking about the difference between these types of geometric things, and it was extremely boring. Okay? You need to pick your heads up. I'm not going to ask you again. Fake it till you make it. If you're tired, I'm sorry. So, line segment. There's not really a difference other than that this one would technically be called a secant line, and this one would technically be called a chord. Do you see why I didn't really tell you about it? Yeah. Okay. So I don't care. You can call it a chord. That's great. Okay, that's the important thing to know. Again, that was supposed to be angle FDC. It's cool if you didn't call it that. It's cool if you missed it. I don't really mind. When I'm looking at angle FDC, what type of angle is that? Yeah, that's an inscribed angle. We already said that ED was, of course, the chord. There's segment BC again, because that was supposed to be the secant line. That was arc, doesn't matter. GF, though, this one's new. GF is actually called the tangent line. Now, that tangent line, so meaning it just butts up to it. Okay, it just butts up to it. It just barely like kisses it in like one spot. They're only touching in one exact little spot. Okay? And in fact, I will tell you that that tangent line is related to the sine cosine tangent that you know. But you won't really learn about that until you're in pre-calc. But they are one and the same. Okay. Some definition stuff. So with that being said, then moving on to 61, this 1A, that would also be a tangent as well. And then the pedestrian walkway at the bottom would still be a chord. Tangent and chord. now here we're gonna talk about some new stuff. Now, I told you guys that I was at a training. So every once in a while, teachers go to these trainings. And while the point of the training was something different, really my takeaway from the training was to be more sympathetic to my students. Here's what I did in this training. I sat in the same chair for 8 hours on Tuesday and for 8 hours on Wednesday. And they talked the entire time. I think probably total my speaking time over the 2 days was 10 minutes, okay? I didn't even write anything down. There weren't even notes to take. I just listened to these people talk for 2 days straight. And it was the most mind-numbingly boring experience of my life. But guess what I had to do the whole time? Sit there, act like I was trying to be engaged. I doodled a little bit because I just couldn't take it anymore, but I was trying hard, okay? Now, my point is to say, A, twofold. My expectations for you, the same, right? However you're feeling today, I'm sorry, figure it out. The second thing is that it's a nice reminder, I try not to talk to you guys that much, right? And you maybe have some fun when I do talk to you the whole time, and you're like, I want to stab your eyeballs out, okay? I get it. So, we're going to try and keep it short and sweet. And the other thing is that I found myself the whole time thinking about my students and thinking about how I was trying to pay attention and she was so boring, I wanted to die, okay? That's dramatic, but, you know. Okay, so here's the other thing. I was just wishing like the whole time that she would tell me like, hey, so we're gonna do, like, I'm gonna talk for this long and then I'm gonna let you guys have snack or whatever. I mean, but like, I was just like hoping for anything where I would be like, there's any end in sight, except like, the only thing I had was like, okay, they've gotta let us for lunch soonish. They'll, like, lunch wasn't even at a set time. Lunch is just like, whenever you're done talking. So I'm like, ugh, like it's getting like, it's like, it's 10, like lunch is probably within 2 hours, like, I can make it, okay? It was bad. So, I try not to do that to you, right? I'm just telling you the stupid story because I'm going to talk about some new stuff today. We're going to talk for like a total of 4 minutes about new content. 4 minutes. Why am I telling you that? Because I understand that if I was going to sit here and talk to you for the next 40 minutes, you'd be bored. I'd be bored. I get it. So, but I'm only going to talk for 4. And then you guys, I'm really not going to talk to you the rest of the class very much. Okay? So, I need 4 minutes. That's what I'm saying. I need 4 minutes where you're like, okay, I can pay attention for 4 minutes. See, like some people need some serious help before I lose my bananas. Yeah, you can help them because it takes a village sometimes. Kimani, are you ready to pay attention for 4 minutes? Like you have to, like there's almost like a window. I picture it in your brain, like this little window. And some of you guys are looking at me right now, and your body is like, okay, I'm paying attention, but the window is closed. Like you're just looking at me the way I was. You're looking at me the way I was looking at the lady, like. I want for lunch. Do I want to go Indian? Do I want to go Thai food? Where's a good Thai place around here? Right, like that's what I was thinking about. For 2 hours while she was talking. So I know, but so like try and like open the shutters a little bit, like get so that some information can come in. Okay? You know, I can tell your eyes are like glazed over. Your eyes are glazed over. Don't break the windows if you have to. Your mental windows. Okay. So here's all to say. I have like 2 things. I have 2 things to tell you. 1, something I didn't tell you last time. Arc length can be measured 2 different ways. Ash, dude, your window's closed. Okay, you can't even hear me. Arc length can be measured 2 different ways. 2 different ways. The way we've done, the way you did in your warm-up, where it's an actual length. Here, you have no actual length given. The other way arc length can be measured is in degrees. Arc length can also be measured in degrees. So, when you're looking at this guy, I could say that the arc length for VGA, I have no actual distance. But if I had drawn an entire circle, how many degrees would I have gone? Great. So I would have gone 360. I skipped 80 of them. So what's the measure of VGA?
280.
Let us, who are bad at mental math, catch up with you. 360 in a total circle. 80 shy of that. Come on, no breaks.
280. 280.
280 is 280, right? 60, 20? Yes. So the measurement of VGA is 280. Now the other thing that we talked about, we didn't explicitly state, but I'm explicitly stating it now, that the central angle is the same as the arc length. All right? So here, this angle, since this is 80 degrees, angle O, also 80 degrees. Also 80 degrees. The central angle is the same as the arc length. Yes.
How come you told me this morning that it was VGA?
Well, probably I was confused this morning. You know, I just got here, I had 2 days of mind numbingness, and then you asked me real quick, I hadn't had my coffee yet, and sometimes I'm not feeling. Okay. I don't know. Okay, now I'm right, I think. I could be wrong. I'm wrong all the time. You guys know this. VGA from B to G to A. No, that sounds good. VGA. That's that. That's great. Oh. Because it's an arc. Did I tell you it was that angle?
Yeah, you did that.
Oh, it's
you're
because
like you're not gonna know, so just guess. You shouldn't.
Oh yeah, I did. That's for later. That's must.
I told you it was 280.
Must card. Okay. This different. Even I was telling you about this, which that's clearly not. I mean, that's clearly not there. You know, like what was I thinking? So silly. Okay. The other thing. So again, this is 90 right here. So what's CD?
90.
Ethan's got it. The rest of you?
90.
90 degrees, right? Fairly straightforward. And I can in fact go one more. What's EIF? Beautiful. Now, we talked about this idea that the central angle and the arc length are the same. We have one last thing to talk about. It's literally a sentence. I'm just going to put it right under your warm-up in G9. Talking more about circles. We are talking today about the inscribed angle measure. Hello?
I'll get it.
Major. Okay. Given a really crazy looking circle. Given a crazy circle. There's my circle. Okay. Now, there's two things I can talk about. Okay, what kind of angle did I just draw dotted like?
Central angle.
A central angle, also up to a central angle. Now, if I do that one, what angle am I talking about here?
All the angles.
Inscribed.
Right.
Yeah, this one, the bolded one, is an inscribed angle. The thing I'm going to say here is that the inscribed angle is half the central angle. It's like if you had a rubber band and you pulled it back. Okay? So, the inscribed angle is half the central angle. Shh, shh, shh. It's half the central angle, which means it's also half of the arc length, right? Because the arc length and the central angle are the same, and the inscribed angle is half of them. All right? That's your big piece of knowledge today. I'm just giving you that one. That's a freebie. All right? With that information, you're going to do this. So, what?
But if it goes to the same points, then how can it be half the arc length?
Because you notice how it's smaller?
Well,
Okay, so here's why I went back and forth on this. I'll come back with you. I'll get back to you. No. Okay. Here's what I was gonna do. I was gonna make you do like investigate, you know. I was gonna make you learn this for yourself, and then I thought, I'll just tell you. But clearly some of you don't like this, so I'll let you. We'll revisit this tomorrow. For now, we're gonna use the fact. Tomorrow we'll look at why. Okay? Deal?
See.
I think that's what I'm gonna do. All right. Huh? You guys want to hear a riddle?
Oh, tell us the
Oh yeah. I already told you. Sure does.
I didn't hear it.
Oh,
No one figured it out?
I didn't hear it. I didn't
Okay, I'll tell you one more time. Two penguins are in a canoe in the middle of the desert paddling. Penguin 1 says, "Where's your paddle?" Penguin 2 said, "Sure does." Now, before you say I don't get it, or before you're lame and you do this.
Oh my
Wait. No, don't. You can ask me privately. Just think. I thought about it on and off for the better part of 2 weeks. And I didn't think about it constantly. It wasn't like I was journaling like, sure does. Wait, sure. What's that? It was like, I wouldn't think about it, and then I would say something like, sure does. Sure do. And my friend would be like, sure does, like the riddle. So I'll keep reminding you, and eventually you'll be like, oh, maybe I'm gonna look at it.
Okay.
So you're gonna work on this. I want you to finish the front. Finish the front. You're using this. You're using this today. You're using this. Finish the front. Yeah. So yeah. So you. Yeah. So you didn't do it the same way. The other way to.
Same thing. Add that to the beginning.
Hey, I realize there, Captain, that you get the same answer. I know that, but they are not the same process. They're different, and it's a different way to think about it. Okay? No, it's not. No.
She's really good at this.
If it was the same thing, you know what?
I'm
then
not saying
you
it's the
guys-
same thing, I said it's pretty much the same.
Well, no, duh.
Okay.
I know it's pretty much the
She's
same.
getting on caps.
Oh, alright.
Okay. Ethan, they're not the same thing.
I know, but they're like the same.
Okay, well, if you can't figure out the second way to do it, sorry. All right, number 5. A few things. First of all, just as a, I wish I would have thought of this earlier. I didn't think I said this earlier. Angles only have 2 sides.
You said that earlier.
No, I said that earlier today. It was like my first realization. Angles only have 2 sides. On your proof quiz you're about to give, I see a lot of people drawing, like, when you're drawing MKL, you're going like this. I see people going like, MKL. You go to MK and you draw it right, but then you like want to close it off, and you've just drawn a triangle, not an angle. No.
Oh, dang.
Angles only have 2 sides. Angles have 2 sides. So when I'm talking about MKL, I go from M to K to L. Hopefully you can see, oh, that's lovely. That's an inscribed angle. It has an arc length right here of 98. Arc length is 98, so what does that mean about the inscribed angle? I haven't heard a number yet.
49.
Woo! 49. 98 divided by 2. Okay?
Okay.
The inscribed angle is half
Oh my
the
goodness.
arc length, or half the central angle.
Okay.
Okay. If I wanted to draw in, right, if I wanted to draw in this central angle right here, I could. This angle, this is 98, but MKL is 49. It is half the inscribed, it's half the arc length. Okay? So again, number 5 hopefully is a little simpler. If you have 84 degrees now for your inscribed angle, what's the whole arc length? What's this whole thing right here? Whatever double that is, 168 degrees. Okay. All right. So those are now 6 is moving on to like a B level question. 6 is moving on to kind of a B level question. Gotta think a little bit, but okay. Anyone want to tell us how they did 6?
I have a question. Where's that 41? Is that like the angle of B or?
It's angle JD.
Okay.
41.
Hey, DJ.
So I'll give you a second to do that. This is what I'm gonna tell us. Hey, stop. How do you do it?
I don't know if I should take it, but could you, since that's, I don't know if this makes sense, but DB is like the diameter, and then you have 41, so you could that be a fraction of it, and then use it to find the
Why don't you suss that out a little bit and see if you can do it? And then- So try and do 6 real quick. I'm gonna give you guys 90 seconds to come up with an solution.
Okay. So,
Then JD is the arc length for this central angle right here. If this leg, these are both radiuses of the circle, so that is the same as that. What type of triangle is that? Isosceles. Don't think about it. So if this is 41 degrees, what's this?
41 degrees.
41. So how can I figure out that angle? What's 41 plus 41?
82.
82, and then I would do what for that angle? 180 minus 82. Whoa. So that was Luis. That was
That's your key. It's the same thing, right?
same thing. Okay, next up, last thing. I would like you, the goal for today's learning is to do 10 or and 13 on the back.
oh, you're gonna,
That's the goal for your learning today.
where's 10?
Now,
It's either 10 on the back. It's either labeled as 10 or 13.
There's no 10.
It might be it's labeled 13
just the
now,
last problem.
Okay.
right?
Hey. If you have a number 10, do that.
If you have a number 13, do that.
Okay, some of you have the top half of the page, some of you have the bottom half of the page. And when I pasted the top half on the bottom half, it messed up all the numbers. So apart. Second of all, you can pretend this was your exit ticket. I'm not going to collect it. It's your goal for today. This is where I want your brain to be able to understand. That's the goal. Okay? Being straight with you. The other thing is I'm going to give you back your quiz. Now listen for a minute. I did put this quiz into your grade. Reason to see when you get back. Okay?
If I get a good grade on this, I'm gonna
If you improved on your score and you want me to enter yours, I will. But you're taking another quiz on proof tomorrow. And here's the deal. I can't handle this. To get a C, please pay attention. You need to use either vertical angles or reflectives. Literally, your reasoning on a C will be given either vertical or reflexive, and then some sort of side to side or side to side or angle side angle over. Okay? So the fact that on the C level you put all kinds of crazy stuff kind of has me baffled, but it's okay. You need to study from this. You need to study from this. If your score improved and you want me to enter it, you need to come talk to me. Keep this. Study from it tonight. You're taking another quiz on proof tomorrow. If you'd like to stay and ask questions during the tutorial, you may. I'm going to ask as you come up. You come up this lane and you go out. Okay, Sam.